Mr. Hammy here. I just thought it would be a great idea to do a couple of extra examples of hyperbola. So, we know that a hyperbola has the equation that looks like this. And we know that that's the exact same thing as writing it like this. Okay, so what happens in slightly different cases? So let's consider this case, y equals 1 over 3 minus x plus 2. Okay, so you see here, this is not in the same sort of pattern here. We don't have x minus k, we've got k minus x. So our task is to basically rearrange this. So first we'll just swap the position of the 3 and the x. Minus x. Oops. So minus x plus 3 plus 2. Okay, so now you see that it's almost here, except instead of x, we have minus x. So whenever we have just like this minus x bit, what that kind of is a reflection in the y-axis. Reflection in the y-axis. So let me show you what I mean. First, I'm going to plot y equals 1 over positive x plus 3 plus 2. Okay, so I'm leaving out the negative sign here. And if I do that, if I leave out the negative sign, well, it's gone up 2. There's our 2. And here we've got a plus 3, so we're talking that plus 3 is the same as minus negative 3. So it means we've gone to the left 3 units. So 3 units. And now we can draw it. Okay, now if I want to do my graph of y equals minus x plus 3 plus 2, and I've said that it's a reflection in the y-axis. So basically everything is going to be reflected over there. So when everything is reflected in the y-axis, well, this horizontal asymptote does not change, because it just, when it's reflected, it will still be 2. However, this vertical asymptote will be reflected in the y-axis, so it'll take it from negative 3 to positive 3. And this part of our hyperbola will be reflected in the y-axis, so that will be doing that. And similarly, this part will be flipped over as well, and so it will be doing this. So there we go, so reflection in the y-axis. Now, there is another way to do this apart from doing 2 graphs, and that is using a bit of clever algebra. So if we go back to our equation over here, what we can do is take out a factor down the bottom. So if we change it to this, we'll take out the negative 1 sign. So we'll take out the negative 1, and we've got x minus 3 plus 2. Now what we can do is put the negative 1, because we've got 1 divided by negative 1, so overall that equals negative 1 divided by x minus 3 plus 2, and we can put that in the other form, minus 3 minus 1 plus 2. And so now we've changed it to now being a reflection in the x-axis, which we're more familiar with. So now if we would just plotted that straight away, we can see it's shifted up 2. We can see it's shifted to the right 3 units, that way 3, so 3, and a reflection in the x-axis. So we know that it's going to be one of those, exactly what we had before. Okay, let's have a look at a second example, another one that looks a bit strange. So let's have a look at this. 1 over 2x plus 4 plus 1. Okay, so here we're not in standard form either, because we've got 2x going on here where we just want x. So once again, we can factorize this to 1 over, we're bringing the factor of 2 out, and we've got x plus 2 plus 1. So now here we've got 1 divided by 2, so that bit's a half. So it's a bit more clear, I think, if we write it in the other form. And we have half x plus 2 minus 1 plus 1. So you can see now it's in standard form, and you can plot that fairly easily. Here's a plus 2, so that means to the left 2 units. We've got a plus 1 over here, so that's up 1 unit, and we've got a dilation of a half going on as well. So here we've put in our asymptotes, up 1, this way 2. It's not reflected, so we can just sketch it straight away. Now we need to show our dilation by showing a point on each, so we might as well show the intercepts going on here. So first I'll show the y-intercept by setting x equal to 0. So y here is equal to a half. 0 plus 2 is 2 plus 1. So what we've got here is a half, and then this bit here, half times half plus 1. So we've got a quarter plus 4 on 4, which equals 5 quarters. So this is 5 quarters up here. And now to find the x-intercept by setting y equal to 0, we have 0 equals a half x plus 2 to the negative 1 plus 1. Take the minus 1 away from both sides, and now times both sides by 2. So we've got negative 2, and we'll do to the power of minus 1 here. So we have negative a half and on this side, and now take away the 2, minus 2 equals x. So x equals minus a half. Take away 4 on 2 gives us negative 5 on 2. So this bit here is negative 5 on 2. So there we go, we've finished. We've done 2 slightly different examples, and we've just noticed that you can change anything that looks weird back into the standard form, which is this form there. So there we go, you should now be able to do every single example of hyperbolas.